Hello everyone, welcome to CIPMAT's Concept Booster session. This is session number 4 and today we are going to learn about trigonometric functions and we will be understanding the various trigonometric functions with the help of graphs today. See, graphs is a very important tool in mathematics because you see that graphs are very helpful in the analysis of inequalities as well as that which values of x this particular function is going to take, which values of y the function is going to take. That is basically the domain and range. So we are going to cover all these concepts in today's session. So it's a beautiful learning session. Please be with me till the end. And of course, if you like the video, please like it and subscribe the channel. So let's get started with the session for today. So first of all, let me introduce myself. I am an IPM student at IIM Indore. Okay, and you can know more about me in this particular slide. This PDF will be provided to you in the description box. So do make full use of it. And CIPMAT is a organization. CIPMAT is an institution who are basically, uh, dedicated towards ensuring that you get your chance to study in an IIM right after class 12 through the IPMAT examinations and JIPMAT examination. So you can check out our courses in our website. The important links for enrolling in our courses are given over here. Also, please visit our social media handles. You can follow us on Instagram, subscribe our channel in YouTube, and you can also join our WhatsApp and Telegram groups as well. All right, so let's get started for today's class. Here are some tips and tricks to crack any kind of aptitude tests. Do go through them and express your views in the comment box. So we know that there are how many trigonometric ratios? We know there are 6 trigonometric ratios. What are those 6 trigonometric ratios which you have learned in your school before? The trigonometric ratios that you have learned in your school before are what? They are basically, one is sine theta, then is cos theta, then is tan theta. These are the most important ones. And then after that, of course, you have the reciprocal of cos theta, which is sec theta, then the reciprocal of sine theta, which is cosec theta, and the reciprocal of tan theta, which is, of course, cot theta. So first of all, let's start our analysis by understanding the graph of sine x. Okay, so we will first of all draw the graph of y equals to sine x. Okay, so many of you may be already introduced to the graph of sine x. Okay, how does it look like? Let's draw and let's find out. So if this is my y-axis and let's say this is my x-axis, okay, I find it a very good practice to ensure that the arrows are given so that it is being distinguished with all the other lines and curves that I draw in the graph. This, of course, is my origin. Okay, now after this, the graph basically looks something of this format. This is a wave kind of graph. Okay, and this is how the graph looks like. Okay, now this is of course not to scale because I have drawn it with my hand. So of course you can see that it's not exactly perfect. However, this is how the graph looks like. It's like a wave. Okay, now the various points you will first of all understand, that is the maximum value of sine x. The maximum value of sine x, okay, this should be a little bit more higher, okay, according to the diagram over here. Okay, now the maximum value of sine x should be what? This place should be 1, and similarly this one, it should be -1. Okay, so the maximum value of sine x is +1 and the minimum value of sine x is -1. Okay, I hope that is clear to everyone. Now this position is basically pi by 2. Okay, and this position, this value of x is pi. Okay, then after that it is going to take this value, which is 3 pi by 2, then this is going to be 2 pi, and then again it is going to reach the value of 1 at the next value, which is 5 pi upon 2, and it will go on in this way till infinity. Okay, then the next one is in the negative side of the x-axis. You will see that the first value over here is -pi by 2. Okay, then over here it is -pi. Over here it is minus 3 pi upon 2, and here it is minus 2 pi, and you can go on till negative infinity as well. Okay, so now what is the interpretation of all these things? So if you clearly see that at pi upon 2, the value of sine theta or the value of sine x is what? It is equal to 1. Hence, I write that sine of pi upon 2 is equal to 1. Similarly, what should be the value of sine pi? The value of sine pi should be equal to 0, clearly from the graph. What is the value of sine 3 pi upon 2? The value of sine 3 pi upon 2 is minus 1. Okay. So sine 3 pi upon 2 is equals to minus 1. So in this way, you can draw the various, you can find out the various values of sine x with the help of this graph. Now, clearly, I can clearly see that what are the different values of x? Okay, what are the possible values of x? Possible values of x for the function f of x is equals to sine x. So basically what I'm talking about is the domain of the function. Okay, domain of f of x is equals to sine x. Okay, this is what I am trying to find out over here. Okay, what is that? Clearly, I can see that the x-axis extends from minus infinity to plus infinity. Hence, this value is going to be from where? Minus infinity to plus infinity with an open interval, or you can also refer to this as the real number line, or you can denote it as r over here. Okay, now similarly, you can see that what are the possible values of y for, what are the possible values of y for, again, y is equals to f of x, which is equals to sine of x over here. Okay, this is nothing but the range of y is equals to sine x. Okay, what is the range of y is equals to sine x? This is going to be what? Clearly, you can see that it starts from here and it goes till here. Okay, and both the values, that is 1 and minus 1, they're included over here. Hence, I will say that, you know, the values are going to lie. The values are going to lie from where to where? The values are going to lie from minus 1 to 1. So this is going to be the domain as well as the range. All right. Now, can you tell me that what is the area of this particular region, this green region that I am marking over here? What should be the area of this particular region? Those of you who are already introduced to calculus, you guys will know that this area can be easily found out by, you know, integrating from 0 to pi, and if you do sine x dx, you will find this out. So what is the integration of sine x dx? It is minus cos x, and if you take it from 0 to pi, you are going to get your answer. So this is minus of cos pi plus cos 0. So what is the value of minus cos pi? Cos pi is equal to minus 1. So it's going to be, since cos pi is minus 1, I'm going to get minus of cos pi as 1, and cos 0 is 1. So this is equal to 2 over here. Okay, so this whole value is equal to 2. And of course, if I just look into this area, this purple area, okay, this area is going to be equal to 1. Okay, those of you who are not initiated with calculus yet, you need not worry about it at all. You just keep in mind that the area of these small parts are going to be 1, and of course the graph is symmetric. Of course the graph is, you know, kind of similar. Okay, every wave is similar to each other, every wave is congruent to each other, in fact. Okay, hence you can say that the areas of every like let's say that if I want to find out this area as well, this is also going to be equal to 1. Okay, I hope this concept is absolutely clear. Okay, now there is a concept of even functions and odd functions. Okay, I know that a function is known as an even function if f of x is equal to f of minus x. Okay, and I know that a function is known as an odd function if f of x is equals to minus of f of minus x. Okay, now can you tell me that whether sine x is a even function or an odd function? Yes, of course, you are right. It is the sine x, y equals to sine x is an odd function. Okay, it is an odd function. Now, what can I say about odd functions? The thing that I can say about odd functions is that it is going to be symmetrical about this line, that is y is equals to minus x. Okay, suppose this is the line y equals to minus x. Okay, and it is going to be symmetrical about this point. So like this point and this point, okay, both of them will be lying at the same distance from this line. Okay, so basically that is what is the meaning of odd functions. Okay, I hope this part is absolutely clear to each and every one of you. Okay, the complete analysis of y equals to sine x is clear to you guys. Okay, now let's move forward and understand the next trigonometric function, that is y is equals to cos x. So let's understand this one as well. So I want to find out the value of y is equals to fx, which is equals to, let's say, cos x. Okay, again, to draw the graph, what I will do, I will take up the y-axis and the x-axis in this way. And of course, the axes are to be mentioned in this way. And this is the origin. And now how does the graph of cos x look like? The graph of cos x basically looks something like this. Okay, this is how it looks like over here. And on this side, it looks something like this. Okay, now of course, again, the graphs are not perfect. Please do not scale it. Okay, but to give you a brief idea about the graphs, this is how it looks like. Now clearly you can see that sine x and cos x, both of them looks like waves, right? So these graphs, okay, these graphs are known as sinusoidal waves. These graphs are known as sinusoidal waves. Both sine x as well as cos x, okay, they are known as sinusoidal functions, या फिर sinusoidal waves. All right, now what are the different values on the x-axis again and the y-axis as well? The maximum value is 1 and the minimum value over here is minus 1. The maximum value is 1 and the minimum value is minus 1 again. Hence, what are the range? What should be the range of this function? The range of y is equals to fx is equals to cos of x should be what? The range of this particular function should be what? Again, from minus 1 to 1 with a closed interval, because both minus 1 and plus 1 are included over here. Okay, now let's see that what are the different values of x it is going to take. Clearly, you can see that the values of x are going to be from minus infinity to infinity. So of course, I can say that the domain of y is equals to f of x is equal to cos of x is again going to be the set of all real numbers. Okay, this is going to be the set of all real numbers again. So this is going to be the domain and range for the graph of y equals to cos x. And again, if I tell you that what are the different values, this is going to be pi over 2. This is going to be simply pi. Then this is going to be 3 pi over 2. This, the maximum value at which it's going to reach 1. Okay, this is going to be 2 pi. And it goes on like this on the other side as well. This is minus pi over 2. Okay, here it is going to be pi. And then after that, here it's minus 3 pi over 2. And here it's going to be minus 2 pi. Okay, now a few more points about this is that, you know, we know that cos of x is equals to cos of minus x. That means f of x is equals to f of minus x. Therefore, it's an even function. Like sine x was an odd function. However, cos of x is an even function. So what does that mean? That basically means that it is going to be symmetrical about the y-axis. It's going to be symmetrical about the y-axis. Let's say if this value is alpha, okay, then this value should be minus alpha over here. Okay, if that value is alpha, then this value should be minus alpha. And again, just like sine x, another point that I would like to mention over here is that, again, this area over here should be equal to how much? This area will be equal to 1. So keep all these things in your mind because these are important, and you know, it will be helpful in a lot of analysis while you deal with trigonometric functions. There is one more thing which I didn't mention in the previous graph, is about the periodicity of the graph. What is the periodicity of the graph, or the period of the graph? The period of the graph is 2 pi. Now, what do I mean by period of the graph? By period, okay, if suppose the period of a function is t, then we say that f of x must be equals to f of x plus t. Okay, in this particular case, the period is 2 pi. What does that mean? That is, you see that after every interval of 2 pi, the graph is going to repeat once again. Okay, from here, okay, from here to here, okay, the graph is like this. Then after that, from here again, if you start, okay, the graph is going to be again the same thing. Okay, so that means the graph is going to repeat like itself, okay, after every 2 pi values of x. Okay, after every 2 pi, not value 2 pi values of x, but from like 0 to 2 pi, it's going to have the same kind of graph. From 2 pi to 4 pi, it's going to have the same kind of graph. From 4 pi to 6 pi, it's going to have the same kind of graph, and so on. Hence, I say that the period of this graph is 2 pi. Similarly, for this graph or as well, I will say that the period is 2 pi. For sine x as well, I will say that the period is what? The period is 2 pi. For cos x as well, the graph is, the period is going to be what? It's going to be 2 pi. So these are the various points that I should mention about the graphs of sine x and cos x. Now let's come to the graph of y equals to tan x. Now tan x is a different kind of ballgame altogether. It's not a sinusoidal function. It's not a wave-like structure. So let's understand the graph of y is equals to tan x. So how does the graph of y equals to tan x look like? So let's say that this again is my x-axis. Okay, this is my y-axis. Okay, and then after that, let's understand the further nitty-gritties of this particular function. Okay, of course, this is my y-axis, this is my x-axis, this is my origin. Okay, now the graph of tan x basically looks something like this. Before I draw the graph, I would like to draw a few dotted lines like this. Okay, one dotted line, let me draw over here. Okay, this is a straight dotted line that I'm drawing. Okay, another dotted line. Okay, and this dotted line I have drawn at x is equals to pi over 2. Okay, similarly, another dotted line I am going to draw, but this dotted line is going to come after at 3 pi over 2. Okay, this dotted line is going to come at 3 pi over 2. Okay, and similarly, it is going to go on like this. Okay, so why am I drawing these dotted lines? You will understand in a while. Okay, now again, another dotted line, of course. Okay, this dotted line is at minus pi over 2, and another dotted line, of course, at minus 3 pi over 2. Now, why have I drawn these dotted lines is because you guys have already you guys must be already initiated with this concept, that is tan pi over 2 is undefined. Okay, tan pi over 2 is undefined. Similarly, tan minus pi by 2 is also going to be undefined. Okay, tan 3 pi by 2 is also going to be undefined. So all these red lines that I have drawn, the graphs shouldn't be on those lines at all. It should not cut the line. It should not touch the line at all. Okay, so how does the graph of tan x look like? The graph of tan x looks something like this. It's going to be asymptotically close to the the lines of x equals to pi by 2, x equals to minus pi by 2. However, it's not going to touch that particular line. Okay, it's going to be very close, but it's not going to be touching the line. Hence, these lines, that is x equals to pi by 2, x equals to minus pi by 2, these are known as asymptotes. Okay, similarly, at pi, at x equals to pi, it will begin 0. And from here again, the graph is going to look something like this. Okay, again, the same kind of graph is going to be repeated. So one thing you can clearly see that this, the graph at this region and the graph at this region are same. And what is the length of this region? The length of this region is pi. Hence, can I directly write that the period of this function is going to be pi? Of course, the period of this function is going to be pi over here. Okay, and similarly, if I draw the other graphs over here, that is minus from minus pi. Okay, the graph is going to look something like this. So this is how the graph of y equals to tan x looks like. Okay, this is what the graph of y equals to tan x looks like. And of course, the graph is going to be continuing at the other places as well. Okay, I'm not drawing everything over here. Okay, the graph is also going to continue like this in the other places as well. So now let's try to analyze that what is the domain of the function, what is the range of this function. So clearly the domain of the function is that it is going to be all real numbers except a few numbers, except the odd powers, of pi by 2, isn't it? Sorry, not odd powers, odd multiples of pi by 2. So how can I represent an odd multiple? 2k plus 1 is an odd number, odd multiples of pi by 2. Okay, where I will say that k is any integer over here. Okay, where k is of course any integer. Similarly, what should be the range over here? The range of the function, that is the value, all values of y which this particular function can take. Okay, what are those values? You can see that from minus infinity to plus infinity, it is going to take all values. Okay, hence the range of this function is going to be r. Okay, or it is minus infinity to plus infinity. So this is the graph of y equals to tan x. Okay, similarly, the graph of y equals to cosec x, sec x, and cot x can also be drawn. They are very much similar to their counterparts. That is, cosec x looks, the graph of cosec x can be easily remembered with the help of the graph of sine x. Okay, the graph of cos x can be easily remembered with the help of the graph of y equals to cos x, and so on. Okay, so let's try to draw the graph of y is equals to f of x, which is equals to, first of all, let's draw the graph of cosec x. Okay, so here I'm not going to do that much of a detailed analysis. Okay, for extremely detailed analysis and problem solving related to these, okay, please join our live courses, and of course everything will be discussed over there in detail, along with your personal personal doubt clearing, and everything will be given to you. Okay, anyway, so let's see the graph of y equals to cosec x. Here is my y axis, here is my x axis. Okay, this is x, this is y, and this time again I'm going to draw some this time what I will do is I am again going to draw some asymptotes. The asymptotes that I will draw this time will be at pi over here. Okay, this is at pi. Then another asymptote that I will draw is at 2 pi. Another asymptote that I will draw over here is at minus pi. Another asymptote, let's say, is drawn at minus 2 pi. Okay, so these are the asymptotes for this particular graph, and of course this is the origin. Okay, now to remember this graph, what I will do is, you first of all draw the graph of sine x. Okay, maybe a dotted line, but draw the graph of sine x. So how to draw the graph of sine x? You see, this is how the graph of sine x looks like, isn't it? We have already seen this. The graph of sine x looks something like this, where this point is 1 and this point is minus 1. See, now how to draw the graph of cosec x? If I draw it, you will see that it's so easy to remember. You see, you start it from here, from 1, okay, and you go like this, and you go like this. You can view this as a reflection of the graph of y equals to sine x, like that. Okay, in that way. Okay, again, you can start from here. You go like this. It is going to be asymptotically close to those lines. Okay, and again, over here, it's going to be like this. And over here, again, it's going to be like this. Here, it's again like this. And the graph will continue like this to infinity, to positive infinity and negative infinity. So this is how the graph of cosec x looked like. Okay, so clearly from this graph you can easily say that what is the domain of this particular function and what is the range of this particular function. You can clearly see that the domains, the domain of this function, that is all the values of x which this particular thing can take, this particular trigonometric ratio can take, is all values of x except the even powers of x, isn't it? So it can take all real numbers except the even powers of x. Even power means 2k and 2k pi. Okay, so r minus 2k pi will be my domain. Here, of course, k belongs to any integer over here. All right, so this will be the domain, that is all possible values of x. And what should be the range over here? The range is, again, if you clearly see that except from this region to this region, it is going to take each and every value of it. Hence, the range of this particular function is going to be what? The range of this particular function is going to be of all real numbers except from -1 to 1. Okay, and this time it's not closed bracket because cosec x can take the value of -1 and 1. So it is open interval 1 to 1 like this. Okay, so this is the domain and the range, and clearly you can see that the graph is going to repeat after every 2 pi interval. Hence, I will say that the period of this graph is equals to 2 pi again. Okay, the period of cos x was 2 pi, the period of sin x was 2 pi, the period of cosec x is 2 pi. However, the period of tan x was what? The period of tan x was only pi, right? So in this way, you can also draw the graph of sec x. Okay, for sec x, if I draw the graph, okay, the graph would be again similar to that of cos x. Okay, you can easily draw the graph of it as well. Okay, I will leave this as a homework to you guys. Okay, because this is just a concept booster session, and I won't stretch the sessions too long. So you can draw the graph of y is equals to sec x, okay, as a homework. Okay, which will be what? Then also let me just give a brief idea about this. Okay, if this is the graph, we know that cos x looks like this. Okay, the graph of cos x looks like this. So the graph of sec x, it will be something in this way. The graph of sec x is going to be something in this manner. Okay, where there will be an asymptote over here. Okay, there will be asymptote over here, there will be asymptote over here. Okay, and this is how the graph of sec x is going to look like. Okay, I'm not discussing this in detail again. Okay, again, you can see that this is pi by 2, this is going to be 3 pi by 2. So again, the domain is going to be what? The domain is going to be all real numbers, that is all values of x, okay, except for the odd powers, sorry, the odd multiples of pi by 2. Okay, what are odd multiples of pi by 2? 2k plus 1 into pi by 2, where k belongs to the set of integers. Okay, where k belongs to the set of integers. So this will be the domain. And what should be the range of this particular function? The range of this particular function is going to be the range of this particular function is going to be what? You can clearly see that except from -1 to 1, except from -1 to 1, it is basically taking all values, right? So it is going to be the set of all real numbers except from -1 to 1 open interval. So that will be the range. And again, the period over here is going to be 2 pi. Okay, the detailed analysis and the proper drawing of the graph, I would leave that as a homework to you guys. Okay, and of course, then after that, we can draw the graph of y equals to cot x as well. Okay, this also I will leave it as a homework to you guys. Okay, you can draw the graph. Okay, but a brief idea about the graph would be something in this manner. Okay, here you can easily draw this particular graph. Okay, the graph of this is going to be of this manner. Okay, it will again have asymptotes at pi, at the even multiples of pi. So at the multiples of pi, in fact, there is no even multiples of pi over here. Here, if I just talk about pi in this cosec x as well, okay, this I shouldn't mention this 2. If I just mention k, that should be enough over here. Okay, similarly over here, okay, for cot x, it's going to be like this. Okay, it looks like tan x only, but a little bit different. Okay, this will be pi. Then again, after that, it's going to be like this. Okay, again, this is going to be 2 pi. And similarly, the graph is going to be like this. Okay, over here, and in these way, the graphs can be drawn. Okay, here it's pi by 2. Okay, here it's 3 pi by 2, and so on. So again, you can do the analysis of domain and range and the period of this function as well. Okay, So these are the main graphs of all the trigonometric functions. I hope you enjoyed this session. You have understood the concepts over here in this particular session. Okay, I would like to take a leave now. Okay, everything, every point that I mentioned over here, it should be totally, you should be remembering each and everything, because these are very important concepts from the perspective of IPMAT. Okay, from IIM Indore's IPMAT, and for other engineering entrance examinations as well. Okay, so these are always going to be helpful in doing any kind of analysis. Okay, whenever you do any analysis related to physics, where in you are doing something related to simple harmonic motion or waves, or maybe you are doing calculus, at that time you will see that these graphs are very much important. Okay, now I am an IPM student. I know that there are some courses which are on differential calculus, integral calculus in the first year of IPM. Okay, there these graphs are extensively exploited, and you have to use these graphs in a lot of places. Okay, so I hope that you have understood the concepts, and in order to prepare for IPMAT and get proper guidance for towards that, okay, you can visit our website and enroll for our live courses. And of course, if you like this video, you can hit the like button, and of course subscribe to our channel. Mention your views about this video in the comment box, and that will be about it for today's session. See you again in one of our next sessions. So thank you so much. Bye bye.